Joining us now is Dobrica Cosic, co-founder and business developer at Podatica. Dobrica's talk From Insights to Intelligence, the future of MMM and MTA in the AI-driven marketing world. We'll explore how AI is transforming marketing attribution and mix modeling to drive better decisions and campaign outcomes. Dobrica, the floor is yours.
No. Oh, okay, perfect. I'll lower the voice now. Sorry for the weather. It's not up to me. Thank you for joining. I'll have some notes beside me, so I hope you don't mind. First, a shout out to the organizers for creating 10 years of awesome events, considering that we started our data journeys in a similar time, and to see how we grow and evolved, and what an event they created out of a niche community is really inspiring. As they pointed out, my name is Dobrica Cosic. First and foremost, I'm a data science specialist at Parkour SC, which is a US company that develops its own decision intelligence platform for supply chain. About a year ago, I co-founded Podatica, which is a consulting agency specializing in implementing data strategies, but also working on end-to-end machine learning deliveries, and most specifically focused on generating nuanced insights from marketing customer journey data. And in case you're still wondering, MMM stands for marketing mix or media mix modeling. MTA is multi-touch attribution. And if you Google these two, you might find a lot of articles stating that they are dead, and I can assure you that they are most certainly not. It's just the way that someone is working on them is transforming over time. Today we're exploring how they work in the AI-driven world, and how we can transform them from tools that generate simple insights into engines of intelligence. We'll start off by explaining what exactly they do, to show some practical examples that are currently in use, and then move on to some additions that can help them scale in the modern world. So to start by understanding a bit of MMM and MTA and their differences, what MMM does is takes a macro level approach to evaluate how different marketing channels impact total sales. It's based on historical data that is used to identify trends, and also to generate insights on channel performance. It also takes into account factors such as seasonality, weather, demographics, political climate, etc. And for instance, it can help determine if increasing spend on a certain channel, such as TV, in a certain time frame can impact sales. On the other hand, MTA is more on a user level, and it assigns credit to each channel in the user journey. So it's micro level. Basically what it does, it assigns all touchpoint contributions and calculates their effect on conversions, and it's used to understand user behavior. So in practice, MMM is frequently used for overall budgeting, while as MTA is used for digital campaign optimization, where you already have a budget defined. So they are different sides of the story, but to make it actionable, really, you should probably use both of them. And why is that? Because the insights that they generate basically serve different purposes. So MMM is strategic and offers insights in high-level budgeting, while MTA excels in short-term planning and fine-tuning of distribution of budgets across channels. That way, when we align this in one version of the truth, we'll have a comprehensive understanding of channel performance in general. So to top it off, a unified model that uses both of them will help us in generating a precise budget allocation, improved optimization of all channels, and to help us with strategic decisions. Now imagine you're launching a new product. Okay. I can take off the coat. Okay. So yeah, thanks. I can't hear the distortion. Thanks. So imagine you're launching a new product. For example, you'll start by using MMM to decide the split among different channels such as TV, digital channels, search media, etc., and then use MTA in real time to adjust the spend based on actual conversions that are happening along the way. All right. Let's move to a real-world application that's called Robin MMM. Robin is basically an established machine learning tool that was developed by Meta as an open source project, and I first encountered this about 3 years ago when it was still in beta. It uses various machine learning techniques such as hyperparameter optimization, ridge regression, time series, etc., to reduce basically what's written here. I don't know if you can see well. Reduce human bias in developing this model, helping align with the ground truth, and also enable this decision-making process to be highly actionable. And in short, it takes the complexity out of MMM and helps people with, I would say, less technical backgrounds to visualize the outputs and play around with different outcomes and see how different budget allocations can help them with return on ad spend. You can also utilize some of the parts here. You can utilize packages such as Profit and Nevergrad, which are used for forecasting and optimization as well. Someone might be familiar from Python with them. The picture is small, so sorry about that. I'll just be fast over this. So this is the UI of Robin tool, which basically helps you, as you can see, it's very user-friendly. You can input the data, choose or change the dependent variable that is usually either purchases or conversions, and add some nuances here. For example, holiday data, which can help in identifying micro trends, especially for holiday sales, which can either spike up or down depending on user activity. And what you can do here is basically play around with you don't have to use all of the features at once, so you can add some features, then remove them, add them to the baseline model or not. So as you can see, this is very intuitive, and the output of Robin is basically what you get is a budget allocator that on the top left, these are the suggestions of initial versus optimized budget allocations. So for this specific example, I tested what would happen if we were not to change the total budget, but just re-optimize the spend in between channels. And as you can't see probably, but I'll try to explain, the dark lines are the current distribution, the light lines are the bar charts are the proposed redistribution, and what this example tells us is if we were to change the Facebook distribution from 67 to 75%, we would generate a 23% bigger response within the same budget. So that means that this channel is highly effective. The down left chart gives an output of the mean response, which practically says how many units in time will it increase when this happens, and the response curve on the right shows the diminishing returns. The yellow line that goes way above is Facebook, and since you see it has a nice slope, it basically tells us that we can extend the spend and yield more returns, whereas some other channels, such as the pink, I think it's Taboola or Native, have a flat line, meaning that if we increase spend there, we won't generate anything, any more returns, any more spends, any more purchases. Moving on to MTA. So this is the other side of the story, and MTA is very interesting because a lot of people think they understand it, and down right you see a lot of models that are used over time. Especially Google has its own predefined model: first touch, last touch, linear, U-shaped, and etc. And the big caveat here is that all of these models, all of these heuristics, is something that someone made up along the way. So in a nutshell, this is not something that is data driven. This is something that is based on some hunch, best practice over time, but in general it doesn't utilize data in a way. As you can see on the top right chart, these connections, these user journeys are very intersected, intertwined. So we need to account for everything that happens here. And so what these traditional methods lack is calculating these paths in a good way, and a suggested tool that can help easily here are Markov chains. Markov chain is explained in a small picture, top left. It basically evaluates conversion probability based on touch point sequences, and it's good because in this process you can have certain touch points reappear over time, so it's not that the journey is linear. People, as you know, when you try to purchase something, you can go to Google search, you go to the website directly, you can have ad campaigns, whatever you want, and this process takes time. So the main mathematics behind this is removal effect. What Markov chains do is they calculate it and basically give us a metric on the strength of this channel. If we were to remove it from the customer journey, how would this affect the purchase or conversions, however we want to define it. And this way it helps us identify the most influential ones. So this is good, for example, for email marketing, because usually emails don't send you directly to the purchase cart. However, if you find by removal effect that the strength of this channel is like 15%, you know very well that you have to leave it there and continue with your strategy. The actionable output of a Markov chain model, as I visualized it in Python, basically the strength of a bar chart represents the actual removal effect. And on the right side we see some channels that have a strong impact on the user journey. In this example specifically it's Facebook and Google Shopping. But what's interesting is that you can notice that there are certain channels here that have a negative number, and what indicates is that they may not directly drive conversions, and they might even deteriorate users, so they can give them false pretensions, or people can close it for whatever reason. But this effect, calculating this effect, is very interesting for channels such as affiliate and paid influencers, paid search, because it can suggest strong downstream effects, because these channels are not something that are usually an end point, but something that drives people to investigate more over time. Obviously, what I explained, even though that there is a bit of machine learning in here, even though if there are traditional tools, they have their own limitations. So MMM specifically is very slow to adapt to real-time changes. So when you set the budgets are basically modeled on daily granularity data, maybe even hourly. and it takes time to adapt because the initial data sets are usually a year worth of data, even more. We cannot account for the impact of brand or creative messaging on the sales or conversions, and it doesn't take into account the time component and all effects that it brings with it. On the other hand, MTA has privacy challenges for collecting user data. It struggles with cross-channel and cross-device synergy, and as some of you maybe are familiar with OS systems, OS 17 update, for example, had iOS 17 update had a huge impact on collecting user data, and all of these models had to be recalibrated. And to top it off, if we don't have conversion defined, we don't have value, so we don't know what is actually driving our users to our marketplace or whatever, and this can come down to different reasons, whether we lost the cookie, we lost the attribution period, but yeah, this, if we don't attach the conversion, we don't have the outcome. And enter AI buzzword. I'll say a lot of AI probably because I don't know, it's the topic, but hear me out, stay with me. So how this revolutionizes marketing models in general is that from 2020 to 2025, so during this time frame, the annual growth rate of attribution models is estimated at around 16%, and the market in general is that 60% of people that are working with models actually believe that AI-driven attribution will be significant in the years to come. The models are expected to reduce costs by 25% and increase revenue by over 15%, but it's not just about profits when we talk about it, because people that actually work and deliver these models believe that this will help them better understand customer behavior, and this is especially visible in B2B world. Okay. So recognizing the impact of every touch point has long been a challenge, and AI's capacity to help us with automated data processing and enabling real-time updates, gathering and transforming a vast amount of data in a short period of time can help us to adapt to new information automatically. And by leveraging these advanced algorithms, these models can dissect complex journeys and attribute conversions to specific touch points and channels with very high level of accuracy. What does this mean specifically for MMM? It can automate processes such as ad stock calculation, and it can help in to run multiple what-if scenarios. So I showed you a solution, an output from Robin, but when you get that output, you get like parallel 15, 20 outputs, and it's up to you to try to optimize it. So an enhanced model can help a retailer predict ROI impact of reallocating budgets from TV to digital channels in a specific, let's say, Black Friday campaign, whatever. But that's just one side of the story. So what I see as most helpful here is that AI can help to generate model results descriptions, meaning that you don't have to look at bar charts and think, oh, is this something that is meaningful to me? How to compare two charts, etc. This is an opportunity for less analytical teams to be on the top of their game, don't pay a significant amount of money for consultancies, etc., and also manage better client expectations in a better way. MTA, I mapped it as a football field because our current customer journeys are chaotic, like traveling, like a football traveling a field during 90 minutes or 120 minutes of gameplay. And the key here is that we need to find a way to understand the sequence details and interactions to have better personalization, because not all touch points are primary oriented towards conversion. We have some passive views of, let's say, social network posts that also have to be accounted for. And by considering factors such as timing, frequency, channel context, algorithms can help find these small details, process real-time data, and help differentiate between these various types of interactions. Also, there's a valid use case for using deep learning for behavior analysis, so that we can group users in segments and find most important ones, and then move to hyper personalization over time. I have a couple of use cases here. So, for example, how can we leverage AI? One is using LLMs to configure sentiment analysis. And what this does, imagine you have a product launch and you have a problem with delivery. Your product delivery is late, and you have a lot of outreach of people complaining that this is happening. You can automatically set sentiment analysis and locate what's happening, and then on top of that sentiment analysis, automate the let's say sending more emails, notifications, banners, messaging to help people stay engaged, to have belief in your brand, and also you can readjust the messaging in general to increase further conversion. Another example is, which is very interesting at this period of year, is campaigns. For example, Black Friday campaign across multiple channels. Imagine you're launching a new product, and what an AI marketing mix model can do is dynamically analyze real-time sales and identify which channels are underperforming and help you recalibrate your spend and move from TV to traditional TV, let's say, to digital, to podcasts, whatever. And this allows brands to increase sales without additional spend, but what is more important is that you'll have a better alignment with actual consumer demand in time. You can also personalize your e-commerce by identifying channels and formats that are most effective for a segment. And when I say formats, I mean messaging formats such as banners, widgets, whatever you like to use. And what we can do is use Gen AI to create personalized content, such as dynamic subject lines, something that calls to action a certain group of users that are highly valuable. You can use it to play with ad visuals, and this will furthermore increase click-through rates and conversions over time. The future of marketing analytics, I cannot emphasize this enough, is predictive, is near real time, and is AI driven. And as LLMs and Gen AI continue to evolve, we'll see that especially business people will tend to focus on accuracy, on playing on, we cannot play with budgets anymore, so we need accuracy, we need it now, we need better ROI, we need quicker responses to market changes, because the competition will go over you. But here's the thing, that will also yield a lot of investment in talent and infrastructure, so a lot of cloud costs, and what I suggest to everyone is to stay up to date with advancements and focus on integrating your strategy in campaigns, but also be wary of all implications on the ethics and data governance side. My conclusion here is, if you're working on a cross-team collaboration and you have some knowledge on this topic, the best way is to empower marketers to act on real-time insights, adapt to changes, I suggest for everyone to embrace experimentation, to stay ahead. So use these tools that I suggested, play with open source, try to find your model that works, stick with it, play around with it before it goes into production. And this will enable smarter decisions and measurable results. AI is here, it's not the future, it's already here, and you can try to predict and shape the outcomes with using these tools that I explained here. And 25, thank you.
Questions?
Hello, thanks for the presentation. What I'm interested in is how do you track impressions in, for example, in traditional TV or influencer marketing, and how do you then incorporate this into this Robin MMM?
That's a good question. Basically, for traditional TV, it's very hard. So you ideally you would like to have data from providers, and a lot of times you need to play. For example, you cannot. I'm speaking for the US market. When you try to promote a product, you cannot buy space directly. You communicate with agencies that have their slots, and then they propose a certain distribution. So this is something that you need to work with these companies, but most of the time it's down to the impression ad stock. And the other question was, beside TV?
Influencer marketing.
Oh, influencer.
YouTube,
Yeah,
example.
influencer marketing is tricky because it produces a lot of downstream effects, and usually what influencer marketing we have to do is expand the attribution period, because a lot of the times these people have to call to action like multiple times over a period. So traditional attribution windows do not work here. So what initially I propose is expanding this period and let's say lowering, because these channels reappear like 3 or 4 or 5 times during an attribution period, lowering their initial impact so you don't credit them as like one impact for every time. So yeah, these are some situations that can help.
Thanks a lot.
Thank you for your presentation. According to the slides with marketing mix modeling, you have curves here with some saturation points on it. And how to validate if these points selected correctly, and also how to validate if the media split from such models is correct?
Well, if we're talking about Robin MMM, for example, yeah, Robin automatically suggests, I guess, 20-ish solutions, depending on the. So you use hyperparameters, and you can dissect it to pinpoint to one solution, which doesn't need to be optimal. So usually, when you use parameters, you generate 10 or 20 different models, and what you do, you need some domain experience, obviously. So these models are all potentially suboptimal in a certain way. So you cannot be 100% sure. You can just look at the numbers that say what are your specific factors. Do you have the budget to expand Facebook spend? Yes, no. Then I don't consider this. That's a waterfall level decision, meaning that sure, you will start by the simplest point. If I don't increase spend, I will yield 20% more outcome, but at what cost? So it's a waterfall decision, so you always start with the model that seems most optimal to your use case, but then if the budgets don't allow it, you go downwards.
I'm sorry, we ran out of time. Thank you, Dobrica. Please, huge round of applause.
Thank you for your time.
Thank you very much for joining us and sharing your knowledge.